Algebra 2. Today we're going to look at section 6.2. We are going to focus on learning how to multiply radical expressions. We will not be doing dividing today. So just multiplying radical expressions. Remember, radical can be a square root, cube root, fourth root, and so on. An expression in math is a problem without an equal sign. So we're not solving equations, we are just simplifying problems. So our goal today is to multiply radicals. Two things you must check for. Number one, make sure the index numbers are the same. You cannot multiply a square root times a cube root, or you cannot multiply a fourth root times a fifth root. So the index number must be the same. That's your first check. Secondly, you're going to multiply the radicands together. Remember, I'd gone over that word with you in the last video. Radicand is the part underneath the radical. So you're going to multiply the radicands together and simplify the product. Because you are multiplying, you are using the product rule that we've had in the past. Remember from the previous units, the product rule says to multiply coefficients and add powers on the same base, the same variables. Alright, so when you are using the product rule, again, you are adding powers on the same base and you are multiplying coefficients. So the general rule is n, which is index number, the nth root of a times the nth root of b is going to be equal to the nth root of a times b. Again, index numbers, these numbers must be the same. Whatever is underneath the radical, you're going to multiply together. They do not have to match. Remember, you can multiply anything together. Once you multiply it, then your job is to simplify using the same strategy we used in the last section. Remember not to give me there's no decimal answers. You can only give me a radical answer. In the last set of notes, we practiced how to do that, like simplifying radical form. We've already done these types of problems, and now today we're looking at multiplication. So example, multiply the following if possible. Number one, the cube root of 2 times the square root of 2. Let me rephrase that. The cube root of 6 times the square root of 2. First, again, you check your index numbers. They must be the same. This problem is not. Obviously, this has a 3 and this has a 2 as an index number. And so for question number 1, you would write not possible or no product, something to that effect. Not possible. Question 2. The square root of -4 times the square root of 2. Notice the index numbers are both 2, so we're good there. And the next thing we do is we multiply the radicands together. And so with this problem, we would just bring down the radical. We would say -4 times 2, which is -8. Then you have to simplify your answer. Please don't just multiply and stop. You must look at it and see if you can simplify. So this time we have a square root of a negative number. We learned in the complex number unit that you cannot take the square root of a negative. It's not real. It's imaginary. So your job is to write it as -1 times 8. Okay, then recognize that, go to your perfect squared list. 8 is not a perfect square. So you now have to find the biggest perfect square that divides into 8, and that would be 4 times 2. You will underline the parts that you can actually simplify. We know the square root of a -1 is imaginary. We know the square root of 4 is going to work out nicely. 2 is not, so we're going to leave it underneath the radical. So the answer to my example 2 would be the square root of 4 is 2, square root of negative 1 is I, and this 2 stays underneath the radical symbol. So 2I radical 2 is the answer for question 2. Okay, example 3. We have the square root of 10x squared and 2 times the square root of 40x. And so because the index numbers are the same, we are allowed to continue. Notice in number 3, there is an extra number involved. That is just being multiplied by the radical. In the first one, you can actually say there's a 1 in front. So you're going to multiply anything you see outside the radical. These numbers have to be multiplied together. 1 times 2 is 2. Then you'll drop your square root symbol down, and you will multiply your radicands together. Okay, so you're going to multiply the 10x squared times the 40x. 10 times 40 is 400. X squared times x is x to the third. You'll then go to your perfect squared list, and you'll look and see, is 400 in the list? And remember, we did start it prematurely. We stopped it early. So you might want to grab your calculator, type in the square root of 400, and see if it actually is a perfect square. If it is, awesome. You write down the answer. If it's not, then you have to go through the entire perfect squared list and locate the highest perfect square that divides into 400. When you type in the square root of 400 on your calculator, it actually does work. And so what I'm going to do, because I'm not ready to answer it yet, is I'm just going to bring down 400 in the next step. And I'm going to go ahead and underline it, so in the next step I know to take it outside. Then I'm going to look at the x to the third. Remember, with variables, we always divide the power by the index. 3 divided by 2 is not a whole number. So we now have to write x to the third as factors. We're going to say x to the second times x to the first. Remember, when you're multiplying, again, you're adding powers. So this problem in red is equivalent to x to the third. Underline the pieces that you can simplify. Notice I've underlined 2 of the 3 factors underneath, so these 2 are going to come outside in the next step. The x to the first is going to have to stay where it is. So the next step, you drop your 2 back down. The square root of 400 is 20. 20 is going to come outside the radical. But remember, it needs to be multiplied by 2, so you'll need to put parentheses around the 20. The square root of x to the second is x to the first. 2 divided by 2 is 1. And then, like I said a second ago, this x is going to have to stay there. So for this problem, you would finish by multiplying 2 times 20, calling it 40. 40x times the square root of x. That would be the best simplified radical answer. 40x radical x. Okay, we'll take a look at question 4. Question 4 says the square root of 12 m to the third n to the fifth times the square root of 6 m to the second n. Index number is 2. 2 here. These are the same, so we can continue. Radicands need to be multiplied together in the next step, or in the first step. So we drop our radical down. We say 12 times 6 is 72. We multiply m to the third times m to the second, which will give me m to the 3 plus 2, or 5. We now look at the n's. N to the fifth times n to the first is n to the sixth power. After you multiply the radicands together, again, your next move, because it's a square root, is to go to your perfect squared list, and you have those in your notes. and you are looking through that set of numbers to see if 72 is in there. Alright, so I'm going to stop there. You know the list of numbers. 72 is not in this list. Again, I do not type this in the calculator. If I do, I get a decimal. I don't want decimal answers. We're trying to write these in radical form. So we're going to go over here, and we're going to use our calculator now to see if 72 can be divided by 4 and work out nicely. And the answer is yes. Then you're going to try 9. 72 divided by 9 works. 72 divided by 16 is a decimal, so no. 72 divided by 25, no. 72 divided by 36, yes. 72 divided by 49, no. 64, no. Next one's 81. 81's obviously too big, so we have 3 choices right now. And remember, you always choose the highest. So I'm going to choose among 4, 9, and 36. I'm going to select 36. 72 can be written as 36 times 2. Next, you're going to look at your m. We have a power of 5. When we divide 5 by the 2, it is a decimal or a fraction, meaning we need to write this m to the 5th a different way. We need to write m to the 5th as m to the 4th times m to the 1st. Next, we look at our n, power of 6. 6 divided by 2 actually works nicely, so the n needs to be just dropped down and underlined. We're going to answer that piece in the next step. Between these two, we know we can take the square root of m to the 4th, and between these two, we can take the square root of 36. So the pieces I've underlined, again, are the numbers or the pieces, factors that need to come outside the radical. Square root of 36 is 6. Square root of m to the 4th is m to the 4 divided by 2, or 2. Okay, so that one's gone and that one's gone. The square root of n to the 6th is n to the 6 divided by 2, which is 3. What's remaining underneath the radical must stay underneath the radical. We've got a 2 in there and an m. So the final answer for question 4, 6m squared n to the 3rd times the square root of 2m. Again, that's how you multiply radicals. Okay, we'll try the last 2, and then you're going to try some on your own. Okay, question 5. Again, we're looking at the index number. We see a square root and a square root. They're both 2. We're good to go. We are going to multiply the radicand times radical. We know we can multiply anything together. So 72 times 10 is going to give me 720. X to the 2nd times x to the 1st is going to give me x to the 3rd. Y to the 4th times y to the 7th, or y to the 3rd is y to the 7th. We add powers when we're multiplying. Now that we've finished the multiplication step, the rest is simplify. You're going to go to your calculator, you're going to type in square root of 720 to see if it's a nice whole number. If it is not, then you're going to have to, in the next step, find the largest perfect square that goes into it. So we're going to try to write 720 a different way. With calculator in your hand, this is your process, and you need to be trying it at home. 720 divided by 4. So 4 does work. I'm just going to drop that to the side. 720 divided by 9 gives me a nice whole number, so 9 works. 720 divided by the next perfect square is 16. 16 works. Wow. 720 divided by 25 is no, that's a decimal. 720 divided by the next perfect square is 36. 36 works. 720 divided by 49. That does not work. Now divide it by 64. The next one would be 81. The next one would be 100. After 100, 11 times 11 is 121. Then we're going to do 720 divided by 144. 144 works. And then when I'm looking at it, 144 times 5 is the other factor. 5 cannot be broken up any further, and so that's how I know I can stop. There's 1, 2, 3, 4, 5 perfect squares that divide into 720. The highest one is the one that you want to go with. If you choose any of the other ones, your answer will not be simplified. Alright, so we're going to come over here underneath the radical. We're going to write 720 as 144 times 5. You're then going to underline 144 because it's the perfect square. Next, you're going to look at your x to the third. We need to break x to the third up because 3 divided by 2 is not a nice whole number. We're going to write that as x to the second times x to the first. Last, you're going to focus on your y. 7 divided by 2 does not work, or does not give you a whole number, I should say. So we're going to write it as y to the 6th times y to the first. And again, you're going to go through here and you're going to underline everything that simplifies. 144, x to the second, y to the 6th. Make that a 1 there. Okay, so we are ready to answer. Square root of 144 is 12. 12 times itself is 144. The square root of x to the second is x to the first. The square root of y to the 6th is y to the third. We copy down our radical. Anything that's not underlined stays where it is. So 5 will stay underneath the square root, as well as your x and your y. So this is your answer. Okay, question 6. 5 cube root of 2x times 3 cube root of 3x to the 5th. We check index numbers, we notice they are the same. We are supposed to multiply radicands together, and because there's numbers in front, we've got to multiply those together. So we say 5 times 3 is 15. We drop our little 3 down with our symbol. We multiply 2 times 3 to get 6. X times x to the 5th to get x to the 6th. We now go to our perfect, this is a cube root, we go to our cube list. 1, 8, 27, 64, 125, and so on. Okay, again, this list is an infinite set. It keeps going forever. 6 is not in that list. 8 does not divide into 6. So 6 is simplified already. There is no perfect cube that divides into 6. So I have to leave 6 where it is. There's nothing else to do with it. So when a number underneath the radical doesn't work on your calculator and give you a whole number back, and there's no perfect cube or square that goes into it, it's already simplified. It stays where it is. You're going to look at your power. We're going to divide 6 by 3, and you're going to end up getting that one to work. So I'm going to go ahead and underline that piece. You're going to drop your 15 down. You're going to answer the cube root of x to the 6th as x to the 6th divided by 3, which is 2. And then, like I said, the cube root comes down, and the 6 must stay underneath. So that's your answer for that question. Alright, so we've done 6 problems, several examples. We have multiplied radical expressions today. Index numbers must be the same. You're going to multiply the radicands together, and definitely do this. Simplify your answers, or simplify your problems.